Hello, everybody. Welcome back again to another Logos Privacy Builders Bootcamp workshop. Great to have you guys today in the session. This is session number 3 now, I think. And we are joined again by Vaclav, who is going to be talking about the Logos messaging and logo storage. And I think there's going to be a couple of demos. There's time for a bit of a Q&A at the end. And if you guys want to keep the chat going, let us know where you're joining from so we can see how international this all is. And awesome. With that said, I will hand over to Vaclav, who will take things over.
Give me 2 seconds before I just generate this QR code, and we'll be good to go. I just need to replay, but you can switch over to me. It's fine. I'm just
gonna let me do that. Side view speaker. Okay, you're up.
Okay.
Oh, Costa Rica, that is cool. Nice place. I was there a couple of years ago. All right, Vaclav, take over.
No worries. No, Costa Rica is good. I haven't been there, but I hope to visit. I've heard good things. Hello, everyone. Hello again. This is me again. I've opened the chat on the side, so I will try to keep an eye on that. I am assuming I have my friends from Logos here who will be feeding you links, because I might not. Yes, we have James. Thank you, James. Hello from Germany. Stefan, have you inscribed something on Logos blockchain today? Because I was testing something and I saw hello from Germany as an inscription. So curious if it was you. In any case, my name is Vaclav. I am a Logos core contributor. I always say that I'm a chaos agent, but they also say that I am a solutions engineer. So whatever fits, whatever makes sense to you. And today, last time we talked about Logos blockchain, and today we will talk about the 2 other pillars, Logos messaging and Logos storage. Today is the day. Today is the day where everything breaks. So this morning I had my electricity in my house fail 4 times, and then I had to go through like whole launch sequence of the solar panels on the roof to work properly and everything. So then I started like finishing touches on the demos, and everything just broke and stopped working. So I have different demos. Maybe we'll see. We'll see if it gets better or worse. I think it's gonna, like, something is gonna happen, right? Anyway, today we talk about the 2 more pillars, Logos messaging and Logos storage. And I have this disclaimer like I had last time. We are Logos. What is Logos? Logos is a fast-moving set of repositories in various languages, and some of them might be broken or incompatible at any given point in time. As James says, they are not broken or incompatible. They are nearing completion. You need to make sure that you know where you look. Don't hesitate to ask. Don't hesitate to bother us with any question or any problem. We are here for you, all of us, right? And the pace is insane. Not insane, it's very fast, but I think also it's insane most of the time. As Alisher says, like, what was the quote? If you are not lost, you are not enough of an explorer, or something like that. So we are all explorers, and I find myself lost all the time. So I'm really good at exploring, I guess. But also, this is not just the repository, but Logos is a well thought through vision with many moving parts coming together for a very long time. And we are accelerating and strengthening the cohesion of things. So even though things break, that's just a 1 step closer to everything working very nicely together. So what is this one about, right? So I've already said Logos messaging, Logos storage, but terms, fun keywords, right? Gossip sub, peer-to-peer, RLN, rate limiting nullifiers, unlinkability, chat SDK, CIDs, mixnet, persistence, I don't know, others. We'll talk about a lot of technical stuff again. We can talk about use cases. The one thing that I want to make very clear is that I'm very, very passionate about these 2 projects, probably more passionate than about blockchain. The reason for that is that how I got into Web3 was through building smart contracts in Solidity. And I was very much in a spot where I would say, like, everything has to be a smart contract. It all is going to live on chain. And then I got to a point where I realized that it's impossible and also even not feasible or not even good, because I was working with some game studios, and I've realized that, like, you cannot put everything on chain, right? Like, you cannot put all the images and all the stuff on chain, and you don't want to, especially if you have like dynamic NFTs or whatever, or game assets. There is a lot of moving parts that are not going to live on chain, but they live on centralized infrastructure, right? Or you go through some centralized infrastructure to access them or things like that. And so I started thinking about, like, where are we? Why are we here? Why are we, like, saying we are building decentralized applications because we are using blockchain, but then everything else is centralized around us, right? And so this is where messaging and storage jumps in, basically, because we see a lot of use cases for these, and we may not realize we need them until something bad happens. Like, when was it? Yesterday or 2 days ago, when Vercel got data leak, and a lot of tokens got leaked, a lot of information, big trouble, right? And so part of the story is that you had to put a lot of trust in a single entity with a single API endpoint, basically, and single kind of security layer, right? And so if it gets breached or leaked or something, it's a trouble. So I'm going to split it into two pieces: Logos messaging first, and then Logos storage. We'll do demo for both, hopefully. I have one demo sort of prepared, and I don't like to do that demo because it's not really showing what we are building right now. It's an old thing. I'll briefly switch to the other terminal with Claude to see whether Claude finished building the other thing, but we'll see. So why decentralized messaging matters? When we say messaging here, it's a loaded term. We don't mean messaging as in Signal, WhatsApp, Telegram. We mean messaging as in system design engineering, where you need to communicate between your services, microservices, instances, users, right? And why does it matter that this type of messaging is decentralized? If you own your infra, then you can do whatever you want, right? You can have it centralized and you control it. But if you don't own the infra, so you rely on software as a service, some APIs, some cloud APIs, you get into problem of, again, censorship, gatekeeping, disruptions. Something stops working and you cannot influence that. Surveillance, typo. It's not surveillance, it's surveillance. So basically, we got into a point where when we started building on internet, we had a lot of stuff running on our own computers under our desks. Self-hosting is a still big thing in, like, privacy and enthusiast layer, but like most people would just rely on cloud, right? And so if that happens, and for example, last year there was the big Cloudflare outage, and half of the internet was down, right? And that's one of the cases where if some of that, like, even Signal was down. So if Signal had some decentralized way of running nodes and running the kind of the aggregation nodes, or whatever they call them, the provider nodes, they could potentially survive this, because it would just automatically switch. It would define different path if there was some way of not having to have hard-coded API URLs or IPs, right? For gatekeeping and censorship, again, if you try to use some service and that service can decide to not serve you, not because you broke the protocol or broke some rules, but just because maybe somewhere else you did something completely unrelated, that's a problem. So how do we achieve privacy in messaging? And I said we don't mean messaging as in, like, texting with other people, but obviously that covers that as well. And I'll mention that. I will explain why I say this. So we achieve privacy by making messages unlinkable. What that means is that if I want to send a message to Alisher, nobody else other than Alisher should know that I have sent him a message. And nobody should know that I have sent a message or that Alisher is receiving my message, right? So those two things are important. it should be that no one knows that the sender sent a message, regardless of to whom, and nobody should know that someone received and processed a message, regardless of from whom, and that connection is completely broken. Anonymity, I should not need to reveal my true identity or my identity to anyone to be able to use and send messages. Encryption, obviously, we want strong encryption with things like double redshift and noise and these things, so that it's future-proof and that it cannot be easily broken. And if a message or a key leaks, it does not mean that the whole conversation is suddenly open to everyone, right? And then we may, for some cases, achieve privacy by using mixnets or something like mixnets, where basically we talked about mixnets in Blend Network in Logos blockchain, but basically that applies to any sort of sending messages between participants. I may not want to broadcast a message to everyone. I may just want to save bandwidth and send it to one participant, but not directly, but through a mixing service or a mixing protocol. So let me check this. No, it's still building. So we're gonna do this one. If you scan this QR code, and I need to wait. Let me just modify this quickly. Where am I here? So I'm gonna paste it in the chat, and I'm gonna edit this one here. The QR code should be correct. So if you scan this, you will get to an application called Kwaku that I have built 2 years ago, I think, to play around with. Back then it was called Waku. Now it's called Logos Messaging. So to play around with that messaging, and the application is not really maintained anymore because we have kind of dropped support for browsers, but it still works. And so I wanted to show you how it can be, how you can use messaging, although obviously in the future, probably not in the browser, but through the Basecamp or some other ways, right? And so what this is a similar thing to Slido. Basically, if you open it and if you are able to connect to the network, which I hope you are, you can ask questions. And I can answer the questions because I am owner of this, right? Hello from the private side. And I can answer questions. The files downloaded, the files downloaded no longer work. Do we need to re-download the updated ones? Which files? And I mean, we cannot have a chat, but I can answer questions, right? And so the idea is that here you are not connecting to any centralized server. You're connecting to a decentralized network of peers. And that decentralized network of peers is relaying messages. So when you send a message, it doesn't go to me directly. It goes to a bunch of other people on the internet who resend the message. And by that, we get the unlinkability. And then we all get each other's messages so then we can all see each other's responses, or we can upvote and things like that. I can't upvote. Why cannot I upvote? Maybe because I'm the owner. I don't know. I don't remember what rules did I set there. Where can I see the decentralized network of peers? Are they already using all the cryptography you cited in the previous slide? So they use noise, for example, to communicate one-to-one, the peers, automatically, because it's all coming from peer-to-peer. And I'll switch to the next slide, I think, and we will start talking about details. So this Logos messaging uses gossip sub from peer-to-peer. It's a PubSub, publisher-subscriber model. So our goal is to get messages from A to B. So from me to Alisher, from me to all of you participants, like we just did, basically, or from you back to me, right? But we don't want any link anywhere, any metadata leaking that A sent a message to B or B sent a message to A, right? And so for that, we are using peer-to-peer under the hood, and we are using something called gossip sub, which is basically you find some peers in some way. So maybe you start pre-configured with a bunch of known peers, and then you discover other peers through different protocols. I have listed some of them here. And so then when you have enough peers, you start receiving messages. And your goal, if you are a full node participating, your goal is to also relay the messages. And as you are relaying messages in the network, you hide your own messages in those relayed messages, right? And so if I send a message, nobody else knows whether it was my message or whether it's message from Alisher that I am just relaying to someone else, right? And so this way we get a kind of standard pops up. So I am publishing on some topic, and everybody interested in that topic is subscribed on that topic, and we all get some messages, and then we process them. And if the message is encrypted in a way that only I can decrypt it, then I am the only one that can actually read it and that understands that this is a message useful to me. And this is basically how Logos messaging works. There are more protocols, more details, but I don't want to kind of go into too much detail from the perspective of like, you don't need to know if you just want to build on top of it. If you want to know, then we can obviously talk about that. Okay, I'm gonna just check if there is anything that I should respond to. How's the wallet address set up? The wallet address is random, generated in the browser, so that it's anonymous. You should be able to connect your wallet. So I'm using Brave browser. So here I have Brave wallet, which is currently locked. So you can connect your wallet. And if you connect your wallet, it will automatically try to find your ENS and display your ENS if you want to. Messaging is not only about people messaging each other, right? Exactly. Messaging in the sense that we understand it and that we use it is about infrastructure. So if my application needs to talk to some other application, if I have multiple instances, if I need to sync between my laptop and my phone, if I need multiple users sync something, I can use Logos messaging for that. And so actually there are use cases. So one, the human communication, that's status.app, status messenger and wallet is using Logos messaging under the hood for people to get each other's messages. Then Railgun, if you are familiar, it's a privacy layer on top of Ethereum and a bunch of other blockchains. So you can use Railgun to do private transactions on Ethereum, and they are using Logos messaging to basically unlink the transaction you are trying to submit with the node actually processing the transaction. So instead of calling an RPC node directly and giving it all the information like we talked last time, all the information about you, so where I am, who I am, and what wallets belong to me because I am sending these transactions. You can do it through Railgun that will do that unlinking, where they have some broadcasters where you basically publish the message on Logos messaging, and the broadcasters get the message and submit it on chain, but they don't know where it came from. They just know it's a valid message signed with fees and all that stuff that goes to them, and then they submit it on chain. Okay, so we have some upvotes here. It's great. What is the strongest and weakest part of Logos messaging right now? I think strongest is the weakest part might be the initial discovery, because right now as it stands, you basically have to have some nodes which you put in as a bootstrap nodes to your node when you're initializing the node connecting to the network. And default is a bunch of nodes being run by Logos. And so that's the same thing as when we did the bootstrapping of our Logos blockchain. The node would initially connect to Logos run nodes. And that is potentially a problem, right? So there are ways of how to do it. You can have like a community-based bootstrap nodes. You can have, you can ask your friends. You can have some other way of discovery. But right now, you need some bootstrap nodes, and that those hard-coded ones are potential risk. If we want to surveil who is connecting to the network, we could buy that, right? The strongest, I think, really, really cool part, there are two pieces to that about Logos messaging, is rate limiting nullifiers, and I'll explain that in a bit. That's the spam protection in the network. And then something called SDS, and I'll talk about that as well, scalable data sync, basically reliability layer on top of an extremely unreliable peer-to-peer network. Okay, let's go back to the slides. So if you have any questions, I'm not gonna go back to Kwaku right now. I just wanted you to experience something that is fully decentralized. It is still hosted somewhere. You're pulling the front end, like eventually in the future, you'll pull the front end from Logos storage. But right now you're pulling it from somewhere, and that is still a centralized server. But the rest of it is just completely decentralized. Like there is no place where a message would go through a database or anything, and it's cached locally and all of that stuff. So you can, like, it's a somewhat local first decentralized application. And I need to rebuild it for Basecamp. I just didn't have time for that yet. Messages can be both public channels and encrypted for peer-to-peer DMs. Absolutely. There is no reason for why message cannot be encrypted. Very specifically, these messages, all of them, are encrypted. You cannot see it very well. Well, you can see it. You can see it here, actually. So here, there are two pieces, and one piece is just a random ID generated from some of the content where you are creating the Q&A, just so that it's kind of deterministic. And this is a randomly generated password, and it's a symmetric password that is used to encrypt all the messages belonging to this Q&A. And so the idea is that on Waku message, on Logos messaging messages network, it will look like gibberish. But for you, because you know the ID and you know the password, you will be able to fetch those messages and decrypt them. And so you can reconstruct the state of this application, basically, right? So you could have a public Q&A. You can not provide a password, and then it will be completely open and public. But even then, you can just encode the password in the URL when you are sharing it with someone or whatever, and that's also completely okay. And there are different ways of encrypting messages. This is just like symmetric for simple use case where I don't really care. It's not for security or anything. It's more of a like so that it's not completely open and public, and I can somewhat limit who can answer or ask those questions. Okay, let's move on. Rate limiting modifiers, the RLN, one of the strongest things, right? So this was co-developed with PSE. They have a new name, but I forgot. James, you may know, but it was Privacy Scaling Exploration. But right now it's called something else, but it's still PSE. It's an Ethereum kind of foundation branch team, something that is developing really cool stuff. And privacy stewards of Ethereum, yes. So this was one thing that we have developed together with them. And what do we want in an open, transparent, public peer-to-peer network for messaging? We want to limit spam. And I don't mean spam as in like marketing material. We cannot really understand the content, and we will not know the content because it's going to be encrypted. But spam as in like someone sending too many messages, hogging the network, dosing the nodes, and we don't want that, right? And we want to preserve privacy while doing that. Again, using Logos messaging should be private by default, and should not lead to you having to say, oh, this is my email address, so I will send some hash of my email address with every single message so that you can rate limit me, right? That doesn't work if we want to keep privacy. And so how do we get these two properties? Well, basically, we generate zero-knowledge proofs with every message that proves that you are a member of some membership set, and you have not sent more messages than N per epoch. And then epoch is some timestamp, and it's like 10 minutes or hour or day, depending on configuration. And you will be in some membership, which is usually a smart contract. And there is some kind of like a commitment. So there is some hash stored in there that is not tied to your actual identity. It's just a random thing that you know. So you know some secret, you make a hash from it, you put it in a contract, and then that says, I can send 100 messages per epoch, so 100 messages per 10 minutes, for example, right? And then you attach this proof to a message, and that proof will basically have, I am sending message 1, 2, 3, 4, 5, and as you get to message either 101 or you try to send message 100 twice, everybody else getting your message will be able to validate that you have sent too many messages. And they will basically drop it. They will not relay it, or they will ignore it. And eventually they may disconnect from you because they'll be like, oh, this is a weird peer. I don't want that peer. He's spamming me. It may be by mistake, but it may also be malicious, right? And so the spam then kind of only hurts locally. So you have some peers that you are connected to, and you start spamming them, they will start dropping the messages. And if there is a lot of spam, they might get somewhat DOSed, but it's not going to propagate to the full network, right? And so this allows anyone to verify that the message is valid and that the peer is not spamming the network. And it's very light. So generating the proof, I think, is something like 300 milliseconds, and actually validating the proof is a couple milliseconds. They are very small, very lightweight, and they were specifically designed for this use case. And so I think this is really, really cool, because you could think about other use cases. So for example, right now, if you go to an actually centralized API, you have to have an API key, but maybe you don't need an API key. Maybe you could use rate limiting modifiers for that. Like, maybe you don't need that, but maybe you could, because then it opens some use cases like anonymous usage of APIs, right? And then the second thing that is very strong that I mentioned is scalable data sync, SDS. I can find that as SDS in throughout the code. So what do we want? We want reliability, right? We want to make sure that if I send a message, it A, gets to the recipient, and B, if a recipient gets a message, he can know that he got all the messages prior to it, and it's not just a random one-off message out of hundreds of others, right? So we want also somewhat a certainty to some degree that we have all messages. And the problem is that peer-to-peer networks in general are extremely, extremely unreliable. Peers come and go, and they are slow and fast, and some things break, and maybe they didn't update, so their protocol is incompatible with some types of messages and things like that, right? And so we need to put some more reliability into this. And so this protocol was developed in that way. So you basically add more metadata to your message. Well, not you, the protocol does. More metadata to the message with things like causal dependency. So my message is after these other messages. It may be a random set of already seen messages. It doesn't have to be like, oh, I'm replying to this message. It can be just like, oh, I've seen these few messages, and I'm going to put them in, like they are hashes, not the full messages. Some Bloom filters so that I can check whether I am actually not missing something very quickly. And then maybe some other history. Dependencies is the history. No, history, we are building the history. Never mind. So, and this is basically like more metadata. And as you are sending these messages, you can also, you may receive a message where in causal history, you have a message that is like, oh, I'm depending on this other message. And you're like, oh, I don't have that. So how do I get it? I'm just going to ask other peers. And that protocol kind of encapsulates that as well. I'm going to just say, oh, missing message, this one. And then someone else having that message may send it back to you, right? And so by that, you can reconstruct the history. And by that, you can have somewhat an assurance that you got all the messages. And it's a base for many things. Because, for example, back to Kwaku, as I designed the protocol, it's extremely unreliable. If you publish a message, or if you upvote a message that you have seen, but I have not seen it, then I will not see your upvote because I have not seen that question because it didn't make it to me. If I had this implemented, which I don't, I would know that there is a message, your upvote, that depends on some question that I have not gotten. And I would ask for it, and then someone else would send it to me. And because of there would be a hash or something, I would know, oh, it's actually this message, and I am applying this upvote to this message. So now I know, right? It's an important thing. And so this is really cool. There are abstractions on top of that. It's like very bare, but like there are abstraction like reliable channels so that you can create a simple channel that's just a log of events basically and things like that. Chat SDK is another really cool thing being built. And I crossed the Chat SDK because it's been renamed to LibChat. And I have a very important note. As I have built probably like 10 applications on top of Logos messaging in the last 2 years, I came to the conclusion that everything is a chat. And I was initially very much against like, hey, I don't want to build another chat application as a demo when I was showing something. I need to build something else. And so I built Kwaku, and I built a calendar, and I built other things. But then when you're building it and you're designing the protocol of like, how do I actually synchronize between the participants, whatever it means, everything is a chat. And so we're building this lib chat, which will allow you to do this very easily. So what do we want? We want forward secrecy, like you have in Signal and other encrypted messengers, where basically if something leaks, if my current state of my phone or whatever leaks with the keys, any single future key is not derivable from that state, right? So I want to make sure that my encryption actually works and that my encryption is not being broken by me, by someone leaking some part of our conversation, for example. And then we want simple API for group and other chats. And what I mean is, like, if I want to build a chat application that is for humans, we can call it a group chat. I want it to be just one API call. Hey, create this group chat, and I get back some object, and then I just publish into that object, and everybody who is part of the group will get the message and will be able to reply. But we can think of other use cases, like, as I mentioned, I built a simple calendar app. And so if I want to have a shared calendar, I need everybody to get a new event and be able to subscribe to that event and maybe modify that event if they have an admin right. And that's a group chat. It's just not humans talking, but the protocol or applications talking to application instances talking to each other. And so how do we get it? We take all the protocols that we have in Logos messaging, like I said, RLN, some encryption stuff, the scalable data sync, the gossip stuff, and we package it in a very nice library with a very simple API that allows us create these different kinds of chats and then publish and receive messages from them. Well-defined and easy API. And we add this encryption on the side. So you can use some simple encryption like I did with like a symmetric key for a group or something. But you can also use a very well-designed, proven encryption like the noise or double ratchet or whatever. The thing also that belongs, kind of part of this, is called DMLS, DEMLS. And I forgot what the acronym means. Hey, if I still have James, because you're a great friend on phone, can you paste what MLS means in the chat so that I don't look like a complete idiot? But basically, it's a way to do a decentralized group chats so that everybody knows each other's key and they rotate as they need to when someone is added or someone is removed. But it's done in a decentralized way. Like Signal has an MLS, they are using MLS, but it's centralized. There is a server that has all this information and manages that. And so if that is compromised, or if someone wants to do something malicious with that, there is an option for that, right? And so we want to have it decentralized so that there is a protocol, and as long as the protocol is correct and works, it cannot happen. And then, so Logos messaging, Waku previously had a part which was a research team, and so that got extracted from Logos messaging when it got renamed and restructured. Multiple listing service. Okay, makes sense, I guess. Yeah, MLS, multiple listing service. Basically allowing people to list their key material so that others can use it to build the group chat, I assume. Before I start talking about this, I have built an app on EVM and Sui blockchain. Currently, everything is on-chain, but the chat system is off-chain. So please let me know, can I use Logos for my chat system in a dApp so that my chat system will also be on-chain? So no, you cannot use it for make your chat system on-chain, because Logos messaging is off-chain, and it's the whole point of it being off-chain. Because if you put it on-chain, then everything has to stay there forever, and we don't want that. We don't think that messaging requires that always. Like for some stuff probably, and that you put that stuff on-chain. But like even a human-to-human chat, there is no point in those messages staying in some forever storage, as long as you have devices where you store those messages and then you can back them up and things like that, right? Or sync them between devices. And that's very specifically case for any communication between services, right? That does not have to be persisted forever. It's usually very ephemeral, and that's how Logos messaging works. It's an ephemeral messaging protocol set of protocols, and so it does not get persisted forever. There are ways how to make it persist, but it's not the main point, the main goal. It is a kind of decentralized register in private. It's a decentralized register. How private? I mean, I would say it's anonymous. Maybe it's not private, because very specifically, I think it's kind of public, but detached from your identity. I don't know that much about DMLS. Like, I know how it works roughly, but like those nuances, I'm not sure. But if you want to ask in Logos Discord, and even if you ping me or James, we'll either find the answer or get you the person to answer it, to explain that, or send a link to specification and things like that. 100%. So capability discovery. So as that research team got extracted, we created something called AnonComms. And if you go to roadmap.logos.co, you can see that there is one section called AnonComms. And this is on them, although it very specifically feeds into Logos messaging and Logos storage as well. So I wanted to mention it here. So what do we want? We want to announce and discover services capabilities. We talked about building a decentralized service marketplaces on Logos messaging for a while, but we never got to actually trying that. And this is kind of the first step you need, because if you want to have decentralized service marketplace, you need a way to discover the services, and you need to be able to do it in a private, anonymous way, to publish a service and discover it, right? And so this is basically building a special kind of DHT, where normally in a DHT you have a key, and then you have some relatively simple value, but here you have a key that is somehow, I think, derived from the values in a different manner than in a normal DHT, where you basically have the capabilities. You have kind of I think it's like a multiple layers. So you have the key, which is derived from capabilities, and then you have the service providers who provide those capabilities. And then you can discover those, and you can search through that DHT, distributed hash table. If someone doesn't know, it's a way to store large hash tables in a decentralized manner, that the hash table is not on any single device. It's distributed in a peer-to-peer network. And so they're building this special DHT. And then basically, when you discover the service with the capability you are interested in, you can use the peer-to-peer mix protocol, which is basically a mixnet built into all of this machinery to access the service, so that you as a client are not leaking your identity and your information, like IP address or peer ID and things like that, to the actual service provider. So if you think about things like AI inference, AI is huge now. So how do I access my AI privately? And we have ways. And for example, Venice AI is very popular for private AI, but you are still accessing through their servers. And so even though they don't know what you're talking about, they still measure who is accessing from where, what service, and things like that. And so this would hopefully allow for building these services as somewhat hidden services, so that you can access them without revealing everything about yourself. So I think this is really interesting as well, and this is under development. And they are, I think in last update they said that they have a prototype ready and they will start testing it properly. So it's going to be interesting to see how that evolves. And so that's kind of what I have for Logos messaging. And I know it's not much, and the reason for that is nothing tangible really. And the reason for that is that I was trying to build a Basecamp module for chat, and that exists, but something was failing. As I mentioned today, is the day of failures. So I couldn't get it working so that I could show it to you and I could point you to the right things. But we can definitely share the links to the chat UI module and libchat and all these things in the Discord. So if you have any questions for Logos messaging, I'm still happy to answer. But the basic idea is that we want to have a very simple API where you say, I am interested in this kind of session or channel, and I want to publish and I want to get messages. And you can see that this is very similar to what we did last time with the Logos blockchain, with the inscriptions, with the difference that here there is no blockchain involved for writing the data to and reading the data from, right? We use blockchain for some pieces like the DMLS, or we use blockchain for the RLN membership sets, but we don't use blockchain for actual transferring or storing the messages themselves. Okay, now Logos storage. Jumping into Logos storage. So why does decentralized storage matters? And it's, I think I've basically copied the slide from the Logos messaging, because it's the same stuff. I'm worried about censorship, gatekeeping. If I store my data with AWS and AWS decides that I no longer can have access to my data, the gatekeeping happens and I'm no longer have access to my data. Disruptions, if the centralized server goes down, if Cloudflare goes down or whatever, I no longer have access to my data. Surveillance, if I upload the data is analyzed. If I access some data which someone uploaded and the data might be malicious, I am suddenly accessing malicious data and I am being seen accessing some bad data, right? Data leakage, I mentioned Versal data leakage. There has been plenty of these recently or over the course of the time. I am running my own photo backup platform at home because I no longer trust Google and Google Photos from the perspective of like keeping my data and not leaking my data and not analyzing my data, right? So those are all the things why somehow a decentralized storage matters. So how do we get through these things? Like, how do we overcome censorship and gatekeeping and all these things? So we want to do a few things. We want to have content addressing. So instead of me having to access some API with some ID, I want to have specifically access my data based on the kind of a content hash, in a sense, right? We always need to use encryption. That's the case for everything, but like you cannot control how the data is encrypted if it's a centralized server, right? I want to have retrieval without central points. If you have ever used IPFS, you have probably used it through some pinning server like Pinata or Infura, and those are centralized services and centralized servers which you access, and it gives you some data. And yes, you can verify the data is correct based on the CID, based on the content addressing. But if they decide to shut that node down, you cannot access the data unless you find a different node or unless you eventually run your own node. But whether you will be able to upload and download from your own node is a question, because how it's designed. And then erasure coding for some of the like replication and making sure the data stays in the network, even though the networks, as I said, peer-to-peer networks are unreliable and nodes go away and break and go down and everything. So I was trying to build this. So last time we have the YOLO board, the TUI, where we were publishing the messages, and I converted it into Claude converted it into a Basecamp module, and it somewhat worked. But then I wanted to add the decentralized storage to it, and it broke. It worked to some degree, but not fully. So I kind of gave up eventually. But basically, the idea was you could also, instead of just pasting a text, you could or writing a text, you could upload an image. So I don't have a demo of this, but I have a different demo because Logos Storage team built a UI for Basecamp, and you can this just leads to this URL. This is not going to be interactive demo. I'm sorry about that. This is just me showing stuff to you. So I'm not going to stay here. But what I'm going to do is that I am going to make this bigger. And I'm going to basically, what I'm doing, I am running this, which is the Logos messaging UI, Logos Storage UI built by Logos Storage team. And you can see my node is up. It's running. Well, maybe you can see that because my resolution is probably too big, but you will have to trust me. It's green, so it's running. And I can upload files here. So we're going to upload a file. I have already uploaded 2 of them. And so then I have a second node running, which is running on a VM in Hetzner in cloud. So it's not here, it's somewhere else. And what I will do is I will upload something here in my local node running on my laptop, and I will fetch it through this node through a very simple, minimal TUI. that I have asked Claude to build 15 minutes before starting this this workshop. So what can we upload? We can upload some text. So we can do echo hello encode workshop participants. And I'm going to put it in a text file, hello.txt. And I'm going to go to this app. I'm going to find the file. Come on, work. Hello.txt. I'm going to click. It's orange. It's beautifully orange. So it means it succeeded. I'm going to copy the CID. This is the CID. I'll show it bigger. These are the CIDs here. I'm going to paste it here. So I'm going to do / paste. And when I click enter, this node running in the cloud in some data center, in some Hetzner's data center, will find this CID in a distributed hash table, realize that there is a peer that hosts this file, connect to that peer and fetch it. And so it should be hopefully fast. It was quite fast. And now you can see I have 3 files here. One of them is hello. And if I open it, V, hello encode workshop participants. Ta-da, we have transferred data through decentralized storage. And I would have loved for you to be able to try it next time, hopefully. I mean, we're going to have a bunch of wipe coding, and I know Alisher already wipe codes with decentralized storage, although it's IPFS, and I will not stop mocking him for that. But I'm pretty sure he will switch to Logos storage soon. So we will soon have wipe coding with these things as well. So this is how it works. And I can jump back to the slides. Sorry, boring demo. Next time, I'm pretty sure next time it's going to be more interesting. So what is a content identifier? We have seen that Z something long string. We want, what do we want? We want no spoof data and we want integrity. How do we get it? We derive an identifier from the content. And how it works, it's not a hash of the content because the data is chunked into small pieces and then that's how it's distributed through the network. And so we chunk the data, we build a Merkle tree, we built a manifest containing some pointers to that Merkle tree, and then from there we derive the CID. So for some reason, historically, I thought that CID is a hash of the file. It's not. It's a hash of a manifest that points to the chunk that create a file. It's not that important. It's something that I discovered recently, so I wanted to exclaim it. But basically, what it makes sure of is that if one chunk changes or if the file changes in any way, the CID no longer matches, right? Even if you change, you could see here that we have the file names and the type, right? And it's part of the manifest. This is pulled from the manifest. This is not derived from the content of the file. Logos storage stores this in the manifest so that it's easier for you to understand what is that file that you are pulling or what's the object that you're pulling. And it doesn't have to be there, but for the sake of simplicity and showcases, we have it there, right? And so if some of these change, any of these, the size, the type, the file name, the manifest will change and the CID will change. So I can be 100% sure that if I know the content identifier of something, I will get it or I will not get it, but I will not get something else, right? Right now, if I access any website, I mean, there are ways of knowing, but if I access any website and I pull index.html, because it's a name-based access, I cannot be sure that I'm pulling what I want to pull. I'm just pulling some index.html, some content, right? And so this kind of solves it to some degree. We want private retrieval. What does it mean? If I retrieve data, if it's my data, I may not care, but I also may care because I may have some data that I don't want to be attached to for whatever reason. But if I'm pulling some other data, maybe it's some data that has been uploaded by a whistleblower, or maybe it's a data that has been prohibited in a country where I am, some book or whatever. I want to make sure that my retrieval is private, right? So we want privacy for clients, and we want unlinkability of client to the content. And so how do we get it? We get it through Mixnet again. So I'm not pulling data directly. So right now, when I did this, I have connected from that VM directly to my laptop through the network layers and asked it to give me that CID. In the future, this would go through a Mixnet basically, and it would not be direct connection, and it would not my laptop would not directly know that this VM is trying to pull from me. And we also need anonymous DHT queries. This is not something that's normally done in DHTs in all the discovery or in peer-to-peer networks and everything. It's basically everything is public, and anybody querying it is querying directly the nodes around themselves, asking for more DHT entries. And so we need anonymous DHT queries for that, because if we are querying some CID that we don't want to be linked to, we cannot just ask everyone else like, hey, give me this CID, right? There is other way, and this is still being developed, how to do it properly. We also want persistence. So what do we want? We want reliability in data persistence and in retrievability, because data gets lost or corrupted. I have just basically had to replace my SD card in my Home Assistant, in my Raspberry Pi, running my Home Assistant, because it started failing. So we know the data is lost and corrupted. And also providers disappear. If I upload my data to some not that reliable data provider or storage provider, they may just go away, right? And so how do we get persistence? We do it through dispersal. So as we chunk the file or the object, we do erasure coding on it, which means basically each chunk gets enlarged a bit or a lot, depending on the configuration, so that you can reconstruct the whole original object from less than full number of those chunks, right? So instead of me having 10 chunks of a file and I have to get all of them, all 10, in the original manner. So if half goes missing, I'm done. I will just enlarge the content and kind of like cross-reference these chunks. And I have more of them and they are bigger, but I get that like I can just get 5 of them and I will still get the whole original file, although 20 of the chunks is gone. This is a normal thing to do in like RAIDs and everywhere. It's not very specific for decentralized storage, but I just want to mention that. And then the question is, how do I actually get the persistence? Because this helps me if I can upload it somewhere as erasure coded chunks. That's great, but how do I make sure that it's copied around, right? So one thing I would like to have is I have a bunch of friends who are also self-hosting crazy people. So they have NAS storage solutions at home and home assistants, and they are hosting a bunch of other things at home, services and things like that. And I'm pretty sure many of people like that are among you, same as I am. And so if I have these friends and they are 5 friends, we can say, hey, I will give you 1 terabyte of my data storage, and you give me 1 terabyte, and the other guy gives us 1 terabyte. And as we all have this terabyte exchange, we can disperse and replicate our data to each other through this erasure coding and dispersal, right? But that works only if you have a bunch of friends and you can rely on them, or is some tight-knit community. But you want anonymous persistence. So the team is working on a way how to do this dispersal anonymously and to kind of random nodes, so that there is no provable linkage between who uploaded the data, who accessed it, and who is storing it. So this is very innovative and crazy piece of work. And what it all leads to, in a sense, is hidden services. If you use Tor and Onion URLs, .onion, those are hidden services. And what it means is that basically you run something, it's running behind Tor proxy, and the Tor proxy connects to the Tor network, and you get assigned some key-based Onion address. And if someone wants to access it, the Tor network finds where it is and goes through a mixnet, in a sense, or onion routing to that hidden service. And so we want something like that, but based on Logos messaging and Logos storage and all those other things that we talked about. So we want to provide services and we want to use services without any metadata leakage, right? And so we can, if we have anonymous and private capability discovery, so I can discover that Alisher runs an AI inference service serving these models. I may want to use that service anonymously as well. So if we have the anonymous retrieval, as I mentioned in Logos Storage, then that retrieval may not mean just retrieving storage, but also retrieving some service response, right? So I could discover Alicia's AI rig, and I could go and hit it with my anonymous retrieval, and I could get back a response to my prompt, right? And so this is kind of where this heads. As I wanted to mention, like right now, Logos storage is relatively boring in a sense, right? It's just another decentralized storage, and it's not that special. I mean, under the hood, it's very special, but like on the surface, the Logos messaging is great, but also seeing all the possibilities is not that easy unless you really are in that headspace. And so when you combine these things together, you get this basically, right? You are able to build a service, provide a service anonymously, and you are able to access the service anonymously without a risk of losing the privacy. And that's it. That's the whole thing. This was, I think, it was less hands-on than the last one. The next one on Wednesday is a vibe coding with Guru, so that's gonna be very hands-on, at least for Guru. I don't know what his plan is exactly, but it's gonna be very hands-on for him. And then the next one after that is vibe coding with me, so that's gonna be hands-on as well, unless stuff breaks again. Then I'm just gonna pretend I was never scheduled for that, I think. Anyway, any more questions, please? We have a couple minutes, and so if you have any questions or thoughts or ideas, could you do a quick comparison with other decentralized solutions, RV, Swarm? What's unique to this one? I think RV and Swarm changed a lot in the last couple of years. So they got closer to actually like having the decentralized access. For example, RV, when I used it many, many years ago, it's probably 5 years, you had to go through centralized gateways. Basically, there was no other way because it was just too much data and too much bandwidth. And so there was the storage itself was decentralized, but the access was not. And so I think that changed. I'm not going to claim because I've not looked too deep. I think that changed, but still you cannot do it completely anonymously, like what I was explaining here. What is our goal for that? Swarm, I think Swarm is even closer, and Swarm had something that was really interesting to me, and that was the browser access for the data, but I'm not 100% sure either, because I have not really tried that. I think the main difference is that we are really trying to make everything anonymous and private, all the pieces of the puzzle, whereas most of these storage solutions are relying on the fact that like everything is open and you have to figure out how to hide your identity rather than it being part of the protocol. We'll see how that goes. So that's what is unique about this one, is the focus on privacy and focus on a true censorship resistance. Because as we talked last time, I don't know if you were here, Kos, but one of the things I said about blockchain is that if you know who is going to propose a block, if you know who is what kind of stake, if you know who is participating in some particular way, you can attack them, or someone can attack those people, and they can toss them, they can DOS them, they can attack them physically, they can censor them, they can try to prevent them from doing what they are doing by preventing them using other services like banks, for example. And so because of that, you need privacy. If you want to have freedom, you need privacy. And we are building all these solutions or these pillars so that you can have the freedom to do whatever you need to do to survive, to live happily. And for that, we need privacy on all layers of the stack, in all the pieces, in all the protocols. I think that's kind of what's special about Logos in general. How do messaging interact with sovereign zone at this point? It doesn't really. One of the goals of the AnonComms team is to make sure that if zone is using, if Logos blockchain is using mix and messaging is using mix, is the same mix, is the same implementation, right? So right now there are different pieces kind of like re-implemented or slightly modified, but that's again my disclaimer slide at the beginning. it's all coming together and it's all being built separately in parallel, but also converging, right? How would a sovereign zone interact with Vacu messaging? Specifically, can a Zone SDK app subscribe to Vacu topics and react to incoming messages as part of its logic? This is core to our thesis. It can. I mean, if you take Zone SDK and if you take Logos delivery, Logos messaging, Logos lib chat, and you bind it together with glue code, and if there is a message coming over a channel in a lib chat in Logos messaging, and the message has all the properties that need to be, I'm going to inscribe it into a channel. Absolutely. And I think it's going to be interesting to see how this plays with, for example, the demo. I need to ask for the demo from Logos blockchain team about the SQLite, because I've seen it in the past, but I've not seen it lately. But they were building a POC or a demo where basically you have like an SQLite zone where you can build a decentralized SQLite database over the channels. And so this would be an interesting place for plugging in messaging, because you don't need to inscribe everything immediately. You can just send some events over messaging, and if they are valid, then a sequencer can inscribe them. I think it's kind of where we are heading with that. Yeah, no, absolutely. Ping anyone, me, James, teams directly in Discord, and we'll be happy to assist and discuss. Aren't just modules that are independent but interrupt, right? Yeah, okay, I'm gonna let James to figure Giacomo's question because I don't have context. Anyway, that's all from me right now. Please jump into Discord. Go Discord, Logos Discord. You have the X accounts and build.logos.co on the screen, or maybe not anymore. Follow and watch the live streams that we do, all that stuff. And please let us know if you start building something with Logos Tech. Let the Logos Devs account know, and we will put you in the live stream, because we want great content from people building on top of Logos. We want to give you visibility, and we want to give you a chance to give us feedback and talk about this stuff. I'll shut up now. Promise.
Awesome.
Really.
Thank you very much, Vaclav. Very good workshop today, and I think you've basically, to be fair, covered all what I was going to say as well. But yeah, hopefully that was an informative workshop for all you guys. And a brief reminder that on the structure Wednesdays we have the next session. This is at 4 p.m. Again, this is going to be with Guru, and it's going to be the first vibe coding session. So we'll be a bit more hands-on. You can hopefully build something cool. And yeah, 4 p.m. on BS team. So that is the same time that this started, just on Wednesday. And then office hours again on Friday, same setup as last week. And questions in the Discord. If you do have any more, I'm sure James and Guru and Vaclav are very happy to answer these. But I think that clears it all up. And thank you very much, Vaclav, for that. And hopefully see you guys again all on Wednesday. Awesome. Okay. Thank you, guys. All right. Bye-bye.